In this video, we are going to look at finding the limit using a table. So if we have a problem, we want to find the limit as x approaches 3 for the function x over x minus 3 quantity squared. What we need to do is we need to find values that are getting closer to 3 from the left and from the right. And so I'm going to pick 2.9, 2.99, 2.999. Go as far as you need to be able to convince you. And then from the other side, 3.1, 3.01, and 3.001. So we want to know what's happening actually at 3. We have our function there. And so we're going to set up this table. And there's a couple of different ways you can do this. You can just plug these numbers in and use your calculator. I actually want to use the calculator to streamline that process a little bit. And so if you have a TI-83, 84, either one, any version of the TI-83 or 84, I know this works. If you go to your y equals and enter your function, x over x minus 3 quantity squared, and then go to your table set, which is second window at the top. And what we're going to do is we are going to change the independent variable, that's our x variable, we're going to change that setting to ask. That way it won't automatically pick the x values and we can pick them. Now let's go to our table, so second and then the graph button, and it looks a little bit different, but we can plug in those x values. So 2.9, 2.99, 2.999. And so if we put those into our table, we get 2.9. If we plug that in, the y value is 290. 2.99, we get 29900, so that's 29,900. And then the next one it gives us is 3e6. Well, 3e6, that's giving us scientific notation. 3e6 means that our answer is approximately 3 with, we're moving the decimal place 6 units, so we'll get 6 zeros. So that would be 3 million. And that doesn't really fit the pattern, but one thing you can do is go over to it and it actually gives you, at least if it is less than 10 digits, it gives you the number. And so our pattern, it's approximately 3 million. It's actually 2,999,000 is actually the better number. And so we do see a pattern happening here. If we pick a number that's even closer to 3, like 2.9999, it's going to get closer. We see that coming from this direction, this part right here is telling us the limit as x approaches 3 from the left of our function. It looks like it's going to keep getting bigger and bigger numbers the closer we get to 3, and so that means it's going off to infinity. Now we can do the exact same process with the numbers approaching on the right, so 3.1, 3.01, 3.001. We see a similar setup here. And so 3.001 again is 3e6, and if we move our cursor over to it, that's 3,001,000. And then we get 30,100 and 310. And so again, we see that same pattern. As our values get closer and closer to a value of 3 on our x's, our values as we get closer and closer to 3 on the y values are getting closer and closer. They're getting bigger and bigger each time. And so it's going off, they're all positive numbers, so it is going off to positive infinity. Since these two are the same, that means that this is going to be that common value, infinity. If we try to plug in x equal 3 here, we do get an error because our function is not defined actually at 3. So what we see here is an error there, but it's approaching the same number on both sides, so that means that the limit as x approaches 3 of our f of x is equal to that common value of infinity. Now some people would say that that doesn't exist, but in many cases we are going to use, since those are the same value, they are both getting bigger and bigger and closer to positive infinity. I will refrain from using does not exist unless they are approaching two separate values. Now if one was positive and one was negative, then they're not the same and that limit would not exist. All right, I'll catch you guys next time.